The topic of this presentation is processing MSMS data in NIST26 chromatogram window. It includes both a video and a handout, and the handout will often contain many items not discussed in the videos, so check it out also. This is part of a full course that's found on my website of the NIST26 with the newly integrated deconvolution library searching for EIGCMS and LCMSMS. This video assumes that you're aware of certain skills that are required to configure and navigate the Chromatogram NIST26 window. If you hadn't already looked at it and you need help, go to the video on configuring and navigating Chromatogram in Windows NIST26. A lot of information is built into the program in their useful help screens. You can find F1 when you go to the chromatogram window, showing a lot of information about processing the chromatogram window itself. And also under the chromatogram window help tips for tandem, you'll find many tandem chromatogram tips that you'll find useful. It's very useful to set the processing mode for the tandem mode, and I'll demonstrate that in the software. If you go to the top here in the chromatogram tab, you'll find that I have both the EI and tandem processing MSMS on my computer. So to simplify the menus, I will go to select spectrum type, select tandem, and say OK. Now the menus are much simplified. Now let's go into the Analyze MSMS input file and set up the other important parameters. The first thing is to select your file. And you'll notice there's only one type of file available within the NIST software for MSMS, and that is the MZML file. To get this type file from your native format from your manufacturer's data system, you can use Proteo Wizard, and we'll talk about that later to easily do the conversion. This will be a positive ion file, so we'll pick positive ion. The tolerances, they're usually set at 20 for the precursor and 40 for the product ions in most cases. Just checking to make sure that was the case for my setup now. Okay. The libraries. I've got the high resolution MSMS NIST library. You can see it's the larger of any of the libraries that came with the NIST software, but you can also use the API and the low resolution if you want to, and even combine it with user libraries in NIST format, or even very large libraries that you can obtain from the internet when they're in NIST format. And all of the results, when you're at the bottom, the included libraries are summarized in the results. There is useful help shown below by clicking on the Help key here, or you can just type F1 on your keyboard to bring up additional help. So I'll do the F1 key, bring up additional chromatogram raw tandem file information. You can also do hybrid searches here, but we'll discuss that in a later video in more detail. And the final thing in this menu is Run in Background. If you want to do other things while your data file is being processed, you can click this and this program will alert you when processing is done. So I'll say OK here, let it run in the background. After you get a lot of things done, it's good to save configuration. So I'll come up to File, Save Configuration, and all the settings that we have entered so far will be saved so you can retrieve them at a later time without having to set up the file every time, or the chromatogram window every time. So you could save mine, such as jlmsms.ini, and save it there. And then you can restore it whenever you want to. So we'll just go ahead and save this. It finished the processing. We'll go take a look and see what we got. And here we will say, if you want to retrieve it, you just say restore configuration and select it, and all your menu items will be set up again. And it's very handy if you process in many different data formats to save your configurations. You note while we were saving the configuration that we're at the bottom here, we're in lib search. If you go to the chromatogram does not allow you to save the configuration in that menu. So to look at our process data, we'll go back to the bottom, go to the chromatogram, and now we'll get all the displayed results on the top, the total ion chromatogram, at the bottom, the list of identifications. It's very useful when you have a lot of things in the baseline. These are the abundances here. So if you look at the abundance axis up here, the dots show you how concentrated a species is by the height of the dot above the baseline. And on the right side, we have the TIC, the total ion current, in the MS1 mode. So sometimes it's useful to see these small levels relatively better because the difference between them are very small in some cases. So you right click on the top, go to Properties, and go to, instead of linear for the abundance axis, we'll go to log. Now it's very easy to see how far or the relative concentrations of these small components versus the large ones. The largest component here is at 100%. As you can see in the table below, relative abundance is 100, and some of these are very small, down in the 0.02%. You can also select things in the bottom list by using the zoom box in the top. So I'll go to the top, and if I wanted to only look at these components here, I form a box with my left arrow and open it up, and you can see the bottom list has changed to only show the things that are shown in the top PIC, or the total ion chromatogram for MS1. And to unzoom, you can go back, right click, and say unzoom. So now let's discuss some of the items that are found in the top menu bar here. So you can reload on startup. If you have that selected, when it comes in, it'll keep the last thing that was being processed, or if you unclick it, you'll have a blank window when you reopen the software. Best hits, we'll discuss that in detail later, but for now, for your initial processing, always leave the best hits on. Do not unclick this. Only IDs can be selected. I'm scrolling the bottom, and you can see for the library ID, there's some no IDs present. If you don't want to see those components, you can just turn that off, say, put it on rather, by turning on only IDs, and they'll go away. But they're really not deleted. You can make them show again, and you might want to do more processing with those in such, maybe the hybrid mode, and we'll discuss how to do hybrid searches by sending things to the lib search window. You can also highlight scores if you want to, by, let's say, highlight everything above 500 for the library fit score. And now you can see that it shows things in yellow that are above 500, but it did not change the list below. It only highlights the little circles for the abundance in yellow here to show which ones fit that criteria. So let's turn that back to none. Background is usually set on any when you come into the program. NIST highly suggests that to get rid of some noise that causes a lot of small peaks that you really can't identify or not worth processing, put it on 75%. And for the majority of the cases, that's what we'll use. But there are some instances in which you pick this number, it might get rid of some components that are very unusual in a sense that their XICs are 0. And we'll talk about that in detail later. A little bit of discussion in this handout, but there's a whole handout about XICs in a later video. So we'll leave that on 75%. This filter scores, you can see when you do it, it changes the bottom menu. And I'm not quite sure how to use this. I put some data. If you go back to the handout, this filter scores and chromatogram menu bar, I put what NIST has there, but I really don't understand how to use this effectively. But you might look at it yourself. Maybe it'll be useful in your work. Let's go back to here and see what else we got to discuss. The threshold, you can set the threshold if you want to. Leave the filter scores off. Go to the threshold, and it can be auto. You could set to see only things that are greater than 1%. And again, you can see when I do that at the bottom, it changes the list and only shows things in the top and the bottom that are correlated with the or not absorption, but an abundance of greater than 1%. I'll set the abundance threshold back to the default value, and notice at the top the number of hits. Every time you change something, it changes the number of hits. So if I go to auto, where I'm not getting rid of things below 1%, I have 31 hits. So this number is a good way to watch as things change as far as how you're filtering things. And always is undoable. So if you go back to 1%, you can go back and forth. You really don't lose the data. It's just not displayed in the top part and the bottom part. So let's talk about some of the things in the bottom part. You have the scan, but the retention time is the most important thing if you want to sort by retention time, and I'll show you how to sort. The score is the library hit, how well it fit the search results. The score unfiltered we'll talk about in a later time. The abundance is the relative concentration. The precursor mass to charge was the precursor selected for the MSMS and how it differed in the part per million of the precursor noted in the library spectrum. The type of precursor, XIC number, we'll talk about in a separate video in detail. You can have the libraries that you searched if you search more than one. And finally, the library ID. And there'll only be one library ID per component within this window. If you want to find alternative structures, we'll have to send it to the lib search. And again, we'll talk about that in a later video. Over the top, you have the unknown in red here, and the bottom is the library hit that's selected for the particular entry. So if you click on things at the bottom, I'm using the arrow keys on my keyboard, you can step through and see how your identifications on the bottom compare to your unknown at the top. So I'm using the arrow keys up and down. So that's very useful. It has the structure at the bottom. I really like the structure displayed in the window, and the default's not that way. So if it's not there, right click, go to Properties, and select Structure on Plot, and say OK. I like to sort everything by retention time when I'm reviewing. So you go to the bottom, left click on retention time, and as you click, I'll just click a second time to bring this earliest eluder to the top. And now I can select that with the left mouse button and use the arrows on my keypad on my keyboard to step through them and review the results. So it's easy to quickly review things and see what looks like a good match. So that would be one way to sort. The other way to sort, let's say I'm just interested in the large components. I'll go over and left click on abundance relative. Now you can see at the top I have the 100% abundance, which I can click on. You can see it's the biggest peak. A little green dot jumps up there when I left click on it. And now I'm going to use the keys on my keypad. And this is a very important thing to learn. So you can go to the handout if you want. But if you use the Shift key after you select the first one, I've selected the first one, and then I go down to and I hold the Shift key down, and I go down to 1.12%, you can see that I've marked only the things between a relative abundance of approximately 1 and 100. Now I can say we've got 31 hits total, but if I right-click on that window and say Show Selected, then I get rid of all the other smaller components, and it makes it easier to review the data. And now I've sorted by abundance, but I really want to go back and review. I'd like to go back to retention time. So I left click on retention time again, twice to get the smallest at the top. And again, I can now select down this very smaller list to decide what I might want to include in my report. So you can essentially sort by anything that you like when you're processing your data. So another way to process it might be the things that have the highest scores. So I'll say show all, go back. Again, nothing really was deleted. It just was not being shown. So show all, we're back up at the top, 31 hits again. Let's sort by score with the top at the top one at the top, and we'll left click that with our left with the mouse and select the first one, and then go to the Shift key, hold it down, and we'll get everything, let's say, with a greater fit than 194, and say Show Selected. And again, I like to sort by retention time for reviewing, so I'll click on it twice to get things in the right retention time order so I can review it. So again, you can always undo this and filter it many different ways to see whatever you want to. Really the options are just almost limitless depending on what your needs are, but it's very easy to do that. The other thing that you need to know on your keypad is to use the control key. If you want to select things or deselect things in a certain order, let's say I want to select this one, I hold the control key down, I go to the fifth hit, I go to this one, and you can just select whatever you want. And if you select it again, it deselect it. So if you have a long list, you can deselect. So learn how to use the Shift and the Control key on your keyboard to get the data in the right format. So now I'm ready to report these hits that I've sorted out here. So I want to get the whole list. So I'll left click in the white space in the bottom to get rid of the selected items. I'll go to the top, select the first one, hold the Shift key while I select the last one. Now I've got the list that I want to export to Excel for reporting. I'll right click on the the blue box at the bottom and say Copy Select Hits to Clipboard. Now I go open Excel and just paste it in there. And now we have a report that I could either retain for later use or actually send to a customer if I wanted to. So that's pretty much how you do the majority of the work within the software to get it to select what you want and get it in a report format after you do the review. So one last thing before we end the video, let's select this peak here. You can see it's a dichlorinated species. What I'd like to do is confirm the presence of the chlorine atoms by looking at the MS1. Of course, the spectrum here is the MS2 where I've selected the precursor, so you lose the information about the presence of the chlorine. So what we need to do is look at the MS1, not the MS2. So go to the bottom here, select the entry that we want, right-click, and say Send to XIC Analyzer. It showed up on my other screen, so I'll click and drag it over here. There's lots of information in here that I won't discuss today, and if you want to see it, you can click the help, and there's a very good help screen that describes everything within this window. What I mainly want to discuss is this isotope window. So if I go up to isotope envelope and deselect it, this is what it actually looks like in the MS1. If you turn the isotope envelope back on, you'll see how the theoretical compares to the actual. See, there's really good comparison here, and it also shows you the differences in parts per million between the accurate one, the theoretical, and the one that was in your analysis. So you can see we have very good match on the isotope envelope and also very good low level part per million errors for the data. So it's a very good fit for this particular dichlorinated type species. So I hope, again, you find this useful information in processing your data. Good day.